Alright, so now let us continue with subtopic 5.2, which is about liquid. Here's the learning outcomes for 5.2. By the end of the lesson, you should know how to relate the properties of liquid to intermolecular forces, molecular arrangement, and molecular motion in explaining shape, volume, surface tension, viscosity, compressibility, and diffusion, and explain the vaporization and condensation processes based on the kinetic molecular theory and intermolecular forces, define vapor pressure and boiling point, explain boiling process, and lastly, illustrate the relationships between the intermolecular forces and vapor pressure and temperature. There are 5 properties of liquids that you should know, such as volume and shape, surface tension, viscosity, compressibility, and diffusion. Okay, so the first properties of liquids I would like to talk about is about volume and shape of liquid. Basically, benda ni kamu dah belajar since high school lagi. Okay, so you should well versed about this. So liquid, dia ada definite volume, tapi dia tak ada shape yang tetap. Sebab kenapa? Sebab liquid ni dia boleh flows, okay, dia boleh mengalir ikut shape of the container, and also dia ada certain volume. Okay, kalau let's say container tu bentuk bulat, bulat lah dia. Kalau let's say container tu bentuk silinder, silinder lah dia. Tapi dia ada volume yang tetap. Okay, and also particles of liquids ni dia arrange closely tapi bukan rigid like solid. And also they will held together by a strong intermolecular forces but not strong enough to hold the particles firmly in place. Therefore, dia punya particles tu boleh move freely tapi tak se-free macam gas. Okay, next properties of liquids that I would like to talk about is about surface tension. Surface tension ni dia ada simbol macam ikan terbalik, macam ni. You tak perlu hafal pun sebab benda ni mungkin you akan guna time university. Okay, untuk cakap pasal surface tension, benda ni benda baru. So, I want you to focus on keadaan partikel yang berada dekat surface. Sebab kita akan measure surface tension ni bila partikel tu, particle of water ataupun molekul liquid molekul ni berada di surface. Okay? Sebab kenapa? Because maksud surface tension ialah the amount of energy yang diperlukan untuk stretch, okay, the surface of a liquid by a unit area, ataupun bila you dapat measure the inward forces that must be overcome to expand the surface area of a liquid. So kiranya actually liquid at surface is different bila liquid particles ataupun molecules of liquid berada di dalam, okay, because liquid punya particles yang berada kat surface ni, diorang tend to have smallest possible area sebabkan oleh surface tension. So macam mana nak faham surface tension? Let's read this out. Okay, basically liquid molecules yang berada dekat within particles within the liquid ni, dia akan experience intermolecular forces in all directions. Sebab tu ada beza. This is particles within the liquid. If you can see, dia punya intermolecular forces ni, dia ada apa tu? Dia dapat experience dekat sekitar neighbor dia, including upwards. Okay, tapi bila kita cakap pasal surface tension, Miss suruh kamu fokus pada partikel yang dekat surface kan. So partikel ataupun molecules yang dekat surface ni, dia punya intermolecular forces tu dia akan pulled downwards and also sideways. Tak sama, ya. Downwards and also sideways, itu sahaja. Bukan dekat all direction. Downwards and sideways bukan dekat atas juga. Sebab kalau ke atas, dia dah jadi lain dah. Dia dah jadi gas. Dia dah vapor, dah vaporize. So, the different tu kalau let's say particle at the surface. Okay, so this kind of intermolecular forces akan pull the molecules into the liquid. Okay, and dia akan menyebabkan surface of the liquid ni to stretch and tighten. Okay, so kat sini bila kita cakap pasal surface tension, kita pentingkan pasal intermolecular forces. Okay, you dah belajar intermolecular forces, you should know intermolecular forces ada dua, which is hydrogen bond and also van der Waals forces. Kalau contoh you ada liquid water, okay, water you tahu the type of intermolecular forces ialah hydrogen bond, therefore dia punya intermolecular forces akan tinggi. Kalau let's say you ada liquid, contohnya ethanol. Ethanol, dia tak ada hydrogen bond, dia ada van der Waals forces, so intermolecular forces dia rendah. Okay, so kenapa penting bila you nak relatekan surface tension dengan intermolecular forces, because the relationships between intermolecular forces dengan surface tension ni adalah directly proportional. Okay, directly proportional. Ni simbol surface tension ya. Surface tension, Miss nak cepat je ni. Okay, so basically the higher the intermolecular force, the stronger the intermolecular forces, the stronger ataupun the higher the surface tension. Okay, because dia punya relationships adalah directly proportional. Okay, kalau let's say contohnya you ada dua jenis liquid, dia suruh bezakan surface tension between water and ethanol, you kena look at dia punya keyword here adalah intermolecular forces, because the stronger the intermolecular forces, the higher the surface tension, the lower the intermolecular forces, the lower the surface tension. Okay, tapi bila kita masuk pasal temperature, okay, since that kita tahu the relationships between intermolecular forces dengan surface tension ni adalah directly proportional, kita tak nak kacau benda ni. Tapi bila masuk saja pasal temperature, dia punya relationship akan jadi indirectly proportional, because kenapa? Kat sini bila you increasekan temperature, intermolecular forces ni akan jadi weak, and also surface tension pun akan jadi decrease. Okay, okay, the next properties of liquids I would like to talk about is about viscosity. Dalam bahasa Melayunya, kita boleh cakap pasal kelikatan sesuatu liquid tersebut, atau the meaning behind it is the tendency of a liquid to resist, untuk menahan diri dia daripada mengalir, daripada flow. Okay, for example, kalau let's say you ada dua jenis liquid kat sini, which is this is contohnya air mineral, and then you ada jenis moisturizer yang bukan water based, yang sangat pekat likat. Kan, you boleh tengok lah dia punya liquid tu flowing differently. Kalau air mineral, you tolak sikit terus tumpah jatuh semua air. Tapi moisturizer ni, you tolak sikit jatuh berapa ketul lah sangat kan. Nak bagi tahu kat sini ya, viscosity of this moisturizer is higher than air mineral. Okay, sebab kenapa? The higher the viscosity of a liquid, the slower it flows. Okay, so that's why moisturizer dia lagi slower lah dia punya flowing to liquid, dia flowing. Okay, molecules yang ada higher kinetic energy, dia move faster. Bila dia move faster, dia boleh overcome intermolecular forces more easily, and that's why dia punya resistance untuk flow tu decrease. Resistance tu maksudnya yang inhibit dia untuk flow tu decrease. Contohnya macam air mineral, dia punya molecules ada higher kinetic energy. Sebab kenapa dia boleh overcome the forces, and also dia senang nak flowing. Okay, compared to molecules of liquid di dalam moisturizer. So we can say here that the relationships between temperature and viscosity is indirectly proportional, because viscosity will decrease kalau you naikkan temperature. Okay, lepas tu kalau relationships between intermolecular forces and viscosity ialah directly proportional, because the higher the intermolecular forces, the higher the viscosity. Okay, and lastly, if you want to compare between molecular mass, molar mass lah, and viscosity. Molar mass ni, kalau let's say you nak tahu molar mass tu tinggi ke tidak, you kena kira lah. You kena tengok the size of the molecule. Kiranya kalau the size of the molecule tu besar, molar mass dia besar, viscosity dia pun akan jadi tinggi juga. Okay, dia akan jadi lebih likat. Okay, the next properties of liquids ialah compressibility. Apakah maksud compressibility? Maksudnya ability untuk sebuah substance tu to be forced into a smaller volume. Okay, contohnya you boleh penyetkan tak liquids? Of course you tak boleh penyetkan liquid. That's why liquid is actually nearly incompressible. Okay, sebab dalam liquid particles tu are very packed closely together tapi tak se-pack solid. So that's why dia ada very little empty space. Macam mana kamu nak kompreskan dia? I tak rasa you boleh kompreskan air. Okay, so that's why liquids actually susah you nak compress compared to gas. Okay, next properties of liquids that you need to know ialah pasal dia punya diffusion. Okay, diffusion rate of gas actually more than liquid compared to solid. Okay, So that's why kat sini sebagai tahu diffusion rate of liquid ni much more slower than gas tapi faster than solid. Gas dia sebab apa? Kalau you tengok gas punya particles pun dia very loose with each other. So dia senang nak diffuse anything. Okay, compared to liquid, dia macam closely packed together a bit daripada solid. Solid memang tak boleh diffuse lah. Okay, so this is the reasons why, because molecules in liquid quite closely packed compared to gas. First, there is lower kinetic energy compared to gas, and also there is stronger intermolecular attractive forces between the molecules, and also the particles can move randomly in 3D space. So how can we describe about vaporization of liquids? Bila kita nak cakap pasal vaporization process ke condensation process, any process in liquids bertukar pada gas, gas bertukar pada apa-apa je lah kan. Keywords dia kat sini ialah pasal intermolecular forces. Okay, so keywords dia intermolecular forces. Kalau vaporization process daripada apa jadi apa? Liquid ke gas. Okay, proses bila liquid ni transform to gas ataupun bila escape of liquid molecules jadi vapor phase ataupun proses di mana liquid particles yang ada sufficient energy dia akan escape jadi from liquid phase jadi ke gas phase. Okay, so dia akan occurs bila molecules on the surface of a liquid dia ada enough kinetic energy untuk overcome. Okay, so keyword dia kat sini kalau you nak cakap pasal vaporization process, dia ada enough energy, enough kinetic energy, liquid particles ni ada enough kinetic energy untuk overcome the intermolecular forces. That's why dia boleh leave the liquid phase dan jadi kepada gas phase. So how can you describe deeper about the vaporization process in a liquid? Bila kita cakap pasal perubahan fasa liquid ke gas ke solid ke any kind of process, condensation ke boiling, anything, kita akan bercakap pasal keyword dia kat sini ialah pasal intermolecular forces. So kat sini you kena tahu, okay, vaporization ni proses ni berlaku bila liquid kan, liquid dia berubah jadi gas. So you kena tahu liquid molecules ataupun particles ni are closely packed together while gas dia sangat far apart. So the key word here ialah kita nak break the intermolecular forces between the liquid supaya dia jadi gas, supaya dia loose jadi gas. Okay, so bila liquid, bila benda yang rapat jadi jarak is because intermolecular forces tu dia akan overcome, okay, overcome the energy yang menyatukan mereka semua. Okay, so macam mana you nak buat ayat tersebut? Okay, so let's look here. Molecules in a liquid ni they actually move quite freely. So each molecules ni dia ada masing-masing ada kinetic energy masing-masing. Okay, contohnya this molecule ada higher kinetic energy, this molecule ada lower kinetic energy. So what happen? Bila diorang always move quite freely and in rapid motion, diorang akan berlanggar dengan one another. So bila berlanggar tu akan berlaku transfer of energy within the molecule. So for example, this lower kinetic energy molecule berlanggar dengan this higher kinetic energy molecule and dia akan transfer energy pada this higher kinetic energy molecule. So bila ada berlaku transfer of energy, makanya this molecule akan ada enough energy to overcome the intermolecular forces yang bindkan mereka together. Okay, overcome the intermolecular forces lah ataupun attractive forces yang menyatukan diorang semua ni. Okay, daripada higher kinetic energy dia ada enough energy to break the intermolecular forces, to overcome the intermolecular forces. Itu dia punya keyword. Lepas tu that's why lah dia boleh loosekan diri dia and jadi gas evaporated off. To summarize, vaporization rate actually depends kepada surface area, temperature and also intermolecular forces of the liquid. Kenapa? Sebab kalau surface area of liquid tu lagi besar, lagi senang molecules tu nak escape jadi gas phase, jadi gas molecules. Therefore, dia punya evaporation rate pun akan jadi increase. Kalau kita cakap pasal temperature, obviously bila you naikkan lagi temperature, makanya molecules liquid yang ada higher kinetic energy ni pun makin bertambah. So lagi senang dia nak escape jadi gas molecules Therefore evaporation rate pun akan jadi tinggi. Kalau cakap pasal intermolecular forces, okay, kalau liquid tu dia ada lower, ada weaker intermolecular forces, maknanya senang nak break the bond, senang molecules tu of the liquid tu nak release jadi gas. So dia punya evaporation rate tu pun akan jadi tinggi juga. Okay guys, next, macam mana you nak describe condensation process? Again, anything yang melibatkan perubahan fasa daripada liquid to gas, gas ke solid ke whatever it is, it depends kepada intermolecular forces. Pertama sekali, you kena tahu condensation process ni dia berlaku daripada fasa apa ke fasa apa. Dia berubah daripada gas ke liquid ataupun proses di mana vapor molecules return to the liquid phase. So, you need to know gas particles ni disusun macam mana. Dia susun jarak-jarak, betul? Okay, dia nak tukar jadi liquid ni. Liquid you tahu, dia jenis rapat-rapat. Okay, so macam mana daripada gas nak tukar pada liquid? Again, the keywords here ialah intermolecular forces. Previously, kita cakap pasal vaporisation process. Daripada liquid ke gas, dia perlukan banyak energy untuk overcome the forces supaya dia jadi break the bond jadi gas particles. Tapi in this case, daripada jauh-jauh you nak rapatkan dia supaya jadi liquid. Okay, so macam mana tu? Okay, so kita tahu condensation process ni, it happens usually, contohnya lah, bila cuaca tu dia sejuk sikit lah, tapi tak adalah sejuk sangat sampai boleh beku jadi solid. Okay, for example lah, klasik punya example of condensation process ni berlaku pada dekat daun pagi-pagi, embun kan. Embun kat daun pagi-pagi bila tengah cuaca sejuk-sejuk macam tu. So gas tu berubah jadi liquid. So macam mana you nak describe dia? So you boleh bagi tahu kat sini. Benda ni berlaku bila temperature of the gas ni kamu kamu loweredkan dia. Okay? Bila temperature of the gas ni diturunkan. So bila temperature of the gas ni diturunkan, maknanya kinetic energy of the gas molecules akan decrease. So molecules ni dia akan move slower. Molecules apa? Gas molecule ni dia akan move, gas molecule ni dia akan move slower. Lepas tu dia akan makin merapatkan dengan each other, rapatkan self closer together. So bila dia makin rapat dengan each other, sebab kenapa dia makin rapat dengan each other? Sebab dia tak ada enough energy untuk overcome the intermolecular forces between molecule. Ini dia punya keyword. Keyword dia kat sini ialah, keyword kat sini ialah gas molecules ni dia tak ada enough energy to overcome the intermolecular forces between molecules. Okay, kalau condensation process, sebab daripada gas tukar pada liquid, dia tak, gas molecule ni dia tak ada enough energy, enough kinetic energy to overcome the intermolecular forces between molecules. Okay, so bila tak ada enough energy to overcome the intermolecular forces between molecule, itulah dia punya gas molecule ni makin lama makin merapat. So bila makin lama makin merapat, jadilah dia lumrah kepada liquid punya molecules, which is liquid punya molecules arranged closely together. Itulah dia macam mana kamu kena describe condensation process. Okay, just now I already explained to you guys about two processes that involve in liquid, such as vaporization process and condensation process. And this one is different because this is about vapor pressure of liquids. Macam mana? Apa tu vapor pressure of liquids tu? Okay, for example, this is a closed container and this is a liquid molecules. Once they evaporate, dia akan menghasilkan gas molecules kan, ataupun kita panggil dia sebagai vapor molecules. So this gas ataupun vapor molecules in a closed system, di atas surface liquid ni kan, apa yang berlaku bila dia hit the wall of the container ataupun dia hit the surface of the liquid, dia akan menghasilkan pressure. So pressure yang dihasilkan daripada vapor molecules ni yang berada di atas surface liquid in a closed container, itulah kita panggil dia sebagai vapor pressure ataupun the pressure of the vapor over its liquid. Okay, vapor of the pressure of vapor over its liquid in equilibrium in a closed container. Dia kena berada in a closed container. Sebab kenapa? Molecules ni boleh escape. So kalau boleh escape, tak adalah kamu boleh tahu vapor pressure ni macam mana. Okay, so it must happening in a closed system sebab These vapor molecules, dia tak akan leave the surface and also dia tak boleh escape from the system. Okay, so basically kesimpulannya vapor pressure of liquids ni terhasil sebab apa? Okay, for example, if let's say this is the liquid molecule in a container, kena in a closed container, okay, and once dia dah turn into vapor, and this is the vapor molecules, and the vapor molecules kena berada di dalam container dan kena always contact with the surface of the liquid. This is the surface of a liquid, so dia kena always ada contact with the surface of the liquid. And also the vapor molecules pun dia kena berada dalam always constant random motion, tapi dia kena always strike ataupun hit the wall of the container. Okay, kena langgar wall of the container, and also dia kena strike the other vapor molecules. So for example, this is the other vapor molecules, so they can strike with each other. Okay, and also as what I have mentioned earlier, dia akan strike the surface of the liquid molecules. This is surface of liquid molecules, dia akan strike the surface of the liquid molecules. So macam mana you tahu vapor pressure term ni exist is because if this is the vapor molecules, okay, and they continuously hit the wall of the container, bila they hit the wall of the container akan keluarkan sejenis pressure. So pressure itulah yang kita namakan sebagai vapor pressure. Next, I want to talk about the boiling of liquids. Macam mana proses liquid tu dia boleh boiling, jadi menggelegak macam tu. Menggelegak tu dah tahap boiling point dah tu. So, apakah boiling point? Apa maksud boiling point? Boiling point ni ialah di mana temperature at which the vapor pressure, okay, vapor pressure ni adalah temperature. Tapi bila temperature of this vapor pressure sama dengan the external atmospheric pressure, pressure of atmospheric external, itu adalah boiling point. Contohnya, kalau dalam soalan dia tanya, what is the temperature at which the vapor pressure of liquid yang dimaksudkan adalah water? Water yang equal to the external atmospheric pressure. Okay, so kalau let's say soalan tu dia tak direct lah bagi tahu, dia nak suruh kamu bagi tahu boiling point of water, tapi dia bagi tahu macam definition macam tu. So what you need to do is you kena ingat balik apa maksud boiling point. So bila temperature of vapor pressure sama dengan pressure of atmospheric external tu, maksudnya soalan tu memaksudkan boiling point. So boiling point of a water memang always 100 degrees Celsius. Itulah temperature boiling point of a water. Okay, so the boiling of liquids ni, it happens bila liquid state ni dia change to gas state. Okay, and then dia berlaku dekat surface and also the inner part of the liquid. Okay, so that's why bila dah liquid tu boiling dan menggelegak, itulah that's why you boleh nampak ada bubbles keluar bila dia tengah menggelegak. Okay, tapi apa yang berlaku bila boiling point tu, contohnya boiling point water adalah 100 degree Celsius kan, untuk water punya boiling point. So kiranya kalau let's say dia dah sampai temperature 100 degree Celsius, itulah water tu punya boiling point. Dia tak akan 101 degree ke no. Dia punya temperature tu akan remain constant je during the boiling process, walaupun banyak dah heat tu dia supply. Okay, lepas tu boiling process memang dia occurs at specific temperature and pressure. For example, water adalah 100 degree Celsius. Okay, to describe boiling process in liquids, this is how you describe it. Okay, you boleh bagi tahu macam mana bila liquid tu dia boil. Okay, proses tu berlaku di mana liquid tu akan turns into a vapor bila you start panaskan dia until dia sampai dia reach to the boiling point. Okay, and then the change from a liquid phase to a gaseous phase ni akan berlaku bila vapor pressure of the liquid akan equals to the atmospheric pressure yang dilepaskan oleh liquid tersebut. Okay, ini adalah this whole thing is the meaning of boiling point. Okay, sebab kenapa? Bila vapor pressure dia sama dengan pressure external atmospheric, itulah temperature itulah yang kita namakan dia sebagai boiling point. Okay, so bila atoms atau molecules of a liquid ni dia boleh spread out enough to change from a liquid to a gas phase, that's why bubbles ni terhasil bila dalam proses boiling in a liquid. And then boiling ni is a physical change because you boleh nampak guna mata kasar you. Macam mana you boleh nampak? Sebab you nampak bubbles. Itulah dia physical change tu you boleh nampak. Because molecules are not chemically altered. The molecules tu still the same. Dia takkan chemically altered. That's why the boiling process ni is a physical change. Okay, next. Bila boiling ni dia berlaku, makanya lagi banyaklah molecules yang energetic. Okay, biasalah you dah panas kan. Benda kalau you panas pun you gerak macam cacing kepanasan. That's what happens to the molecules as well. Okay, bila you cucuk panas masih ada jadi energetic. Okay, and then that's why daripada liquid dia boleh tukar kepada gas phase. And then bila spread out and it can form bubbles. Okay, dia boleh form the bubbles and energy sangat diperlukan untuk berubah daripada liquid to gas phase. And then bila ada heat supply, dia akan overcome lah the bond between the water particles. So liquid ni dia ada intermolecular forces dia sendiri. So bila ada heat supplies, okay, molecules tu dah mengedik-gedik jadi energetic. Lepas tu dia akan overcome lah the bond between the water particles. So dia akan break lah the bond and that's why dia jadi gas. Okay, sebab dia punya kinetic energy tu dah increase. Ini dia punya keyword dia because bila you boiling, kinetic energy tu dah jadi increase. Okay, therefore the temperature of liquid akan remains constant during boiling. That's why lah kalau let's say boiling point of water 100 degrees Celsius, 100 degrees Celsius je. Tak jadi more than that. And this is a graph that shows the temperature versus time. This is the temperature versus time. Okay, yang shows a constant temperature as long as water is boiling. This is, if you can see this over the time, when dia dah sampai dekat boiling point ni kan, dia akan constant. Okay, constant je. Because boiling temperature will not change at all. Okay, unless semua tu dah jadi vapor. Contohnya lah, you kan pernah kan kadang-kadang tak tahulah pernah ke tidak kan. You biarkan je air tu boiling dekat atas periuk sampailah dia kering. Sampai dia dah kering tu barulah dia boleh jadi more than 100 degrees Celsius bila dah everything turns into gas. Okay? Okay, next. Apa kaitan intermolecular forces dengan vapor pressure? Apakah relationship between these two? So basically, nak cakap kat sini, the stronger the intermolecular forces between the liquid molecules, the lower the vapor pressure. Because kenapa? Particles dekat dalam liquids ni are in constant motion. So basically, diorang punya relationship ni is directly ke indirectly proportional? Indirectly proportional. Okay, sebab kat sini dah bagi tahu the stronger the intermolecular forces, the lower the vapor pressure. Okay, so dia punya relationship between IMF versus vapor pressure ni ialah indirectly proportional. Okay, and then next, liquids yang ada weak intermolecular forces are very volatile. Apa maksud volatile ni? Volatile liquids ni dia ada higher vapor pressure. Okay. Okay, sebagai contoh, intermolecular forces between intermolecules ni actually weaker than ethanol. Okay, so tadi kita tengok relationship between intermolecular forces dengan vapor pressure ni ialah indirectly proportional. Kiranya kalau let's say semakin lemah intermolecular forces tersebut, semakin tinggi the vapor pressure. Okay, so nak kata kat sini, sebab ether ni dia ada weaker intermolecular forces compared to ethanol, that means this ether dia akan ada higher vapor pressure compared to ethanol. Okay, so let's see the answer. Yes, the less energy will needed to overcome the weak intermolecular forces in ether than ethanol. Sebab kenapa? Sebab kenapa dia ada higher vapor pressure? Because senang nak break the molecules, okay? Sebab dia senang nak break the molecules, okay? Sebab itulah dia senang jadi vapor. Sebab dia ada weaker intermolecular forces. Therefore, ether tu dia more volatile than ethanol and dia ada higher vapor pressure. Okay, kita gunakan term volatile ni bila you handle chemical reagents. Okay, bila you handle chemical reagents, contohnya ether ni lah. Between ether dengan ethanol. You tahu ether ni is more volatile than ethanol. That's why you kena carry it out dekat fume cupboard sebab dia senang nak jadi vapor, dia senang nak kering, macam tu lah. Dia senang nak vaporize, macam tu. And also dia senang nak terbakar. How about vapor pressure dengan temperature punya relationships? Okay, actually there is a non-linear relationships between vapor pressure and also temperature in a liquid lah. Okay, as the temperature of a liquid tu you naikkan, okay, the molecules dia akan obviously move energetically sebab apa? Sebab dia punya kinetic energy pun increase. And also that's why ada greater fraction yang of the molecules yang boleh escape untuk jadi vapor phase. Thus, vapor pressure akan increase with increasing temperature. So therefore, okay, if you want to know the relationships between temperature and vapor pressure is actually directly proportional. Sebab dia nak kata kat sini apa? The higher the temperature, the higher the vapor pressure. Alright, so I would like to say here that sebagai kesimpulannya, untuk simpulkan everything, okay, between temperature dengan vapor pressure, dia punya relationships adalah directly proportional. Although that dia non-linear, but makin you tinggikan temperature, makin vapor pressure tu pun makin tinggi juga. Tapi as previously, kalau nak comparekan dengan intermolecular forces, okay, the lower, the weaker the intermolecular forces, the stronger the vapor pressure. Diorang punya relationships indirectly proportional. Sebab apa? Sebab bila intermolecular forces ni lemah, makanya attractive forces between molecules tu akan lemah. Okay? Attractive forces between molecules akan lemah. So bila attractive forces between molecules tu lemah, makanya dia punya bond tu tak kuat. Bila bond tu senang nak terlerai, makanya akan ada banyaklah molecules yang boleh escape jadi vapor. Makanya banyaklah vapor pressure kat situ.